Dear students, in JEE 2024 Phase 1, this question was from chapter Electric Charges and Electric Fields. Question is, a particle of charge minus q and mass m moves in a circle of radius r around an infinitely long line charge of linear charge density plus lambda. Then time period will be given as, consider K as Coulomb's constant. Option 1, T equal to 1 upon 2 pi r under root m upon 2k lambda q. 2, T square equal to 4 pi square m upon 2k lambda q into r cube. 3, T equal to 2 pi r under root m upon 2k lambda q. 4, T equal to 1 upon 2 pi under root 2k lambda q upon m. Now see here, in the question it is given to you, particle of charge minus q and mass m moves in a circle of radius r around infinitely long line charge of linear charge density plus lambda. तो यहां पे ये जो लाइन चार्ज डिस्ट्रीब्यूशन है वो पॉजिटिव चार्ज डिस्ट्रीब्यूशन है एंड द पार्टिकल दैट इज विथ चार्ज माइनस q. So when this particular particle is revolving around this line charge distribution, तो required centripetal force that will be provided by attractive Coulombian force by this line charge distribution, right? और हमें फाइंड आउट करना है टाइम पीरियड फॉर द रिवॉल्यूशन ऑफ दिस चार्ज्ड पार्टिकल. सो हियर द रिक्वायर्ड सेंट्रीपिटल फोर्स mv square by r will be provided by this attractive force by line charge distribution. So if electric field in the surrounding of this distribution is E, then the force on charge, that is q into E, which will provide the required centripetal force. So we can write mv square by r, that is q into E. Now E for the infinite line charge distribution, that is given by lambda upon 2 pi epsilon 0 r into q, where r, that is the distance from the line charge distribution of this charge q. Now we can write here v square, that is equal to lambda upon 2 pi epsilon 0 m into q. So from that we can write v equal to under root this one. Now we want time period. Now time taken to complete one revolution, capital T, that is equal to, so distance that is 2 pi r when one revolution is completed, upon speed that is v. So we can write v equal to 2 pi r by t. As per that, t equal to 2 pi r by v. Now in this equation, if we substitute this particular value of v, then we can write t equal to 2 pi r into 1 upon v. So 1 upon v, that is reciprocal of this one. So 2 pi epsilon 0 m upon lambda q. But see here, in option, the Coulomb constant is introduced, k, and k, that is 1 upon 4 pi epsilon 0. So here we have to introduce 1 upon 4 pi epsilon 0. So rewrite this one, 2 pi r into under root. Now multiply and divide by 2. So here we can write 4 pi epsilon 0 m upon 2 lambda q. Now this 4 pi epsilon 0 that you can replace by 1 upon k. So you can rewrite t equal to 2 pi r under root m upon 2k lambda q. Now see the options. As per given options, our answer that match with option given to you in 3. So our answer that is option 3. Clear बच्चों?